Welcome, everyone, to another episode of Heat Treat Radio. Today, we've got the extreme pleasure of having a panel of experts here to discuss hot isostatic pressing. I'm your host, Doug Glenn, publisher of Heat Treat Today and also the host here of Heat Treat Radio. Would like to first introduce briefly our panelists. I'm going to ask each of them also to discuss their own background briefly. And then we're going to jump into a series of questions just to try to bring us all up to date on the latest developments and the trends in the hot isostatic pressing market. So I'd like to first thank, by the way, the HIP panel for the International HIP Committee and their triennial event, the International Conference on Hot Isostatic Pressing, which most recently took place in Aachen, Germany back in April of this year, 2025. And we'll hear more about that committee and that event in a little bit, but I do want to thank them for sponsoring this episode of Heat Treat Radio. So what I'm going to do is just very briefly introduce each of these six gentlemen, and then we'll jump into questions. First individual I want to introduce has really been instrumental in helping us set up this panel. So Cliff, first thing I want to do is just thank you for your time and helping to get this all put together. Appreciate it. This is Cliff Orcutt, Vice President of American Isostatic Presses, Inc. from Columbus, Ohio area. And I'm going to mention with each of these gentlemen what it is they do in a very brief sense and how they can contribute. Cliff's organization actually builds the HIP equipment, all right? It builds and services it. So he's a manufacturer of hot isostatic pressing. Next individual is Victor Samarov, VP of Engineering at Synertech PM in Garden Grove, California. And Victor is a powdered metal part manufacturer. So you've got a different role there. Next individual, Soumya Nag from Oak Ridge National Laboratory in Oak Ridge, Tennessee, government-funded multidisciplinary R&D with the motto of solving big problems. Okay, so we'll hear more about that later. Next is Mike Conaway, Managing Director of Isostatic Forging International Limited, also out of Columbus, Ohio. And Mike heads up an alliance of organizations that build, own, and operate HIP equipment. Okay, so all around the world. So that'll be his perspective on this, on the HIP market, will be interesting as well. Next is Dave Gandy, Principal Technical Executive in Nuclear Materials at EPRI, which is the Electric Power Research Institute, where they've got locations all across the country. And they're involved in R&D and commercialization of HIP equipment and processes. So that's David. And then finally, last but not least, is Oscar Martinez, Regional Sales Manager for Bodycote HIP North America, located in Dallas, Texas. And they are HIP or toll, they're HIP toll processors. So they're actually doing the processing of HIP. So that's it. That's our panel. So I want to jump into the questions here quickly so we can move through and let these experts do the talking. So Cliff, go ahead with your background, please.
Yes, I'm Vice President of the American Isostatic Presses. I'm also Chairman of the International HIP Committee. I've been in isostatic pressing over 45 years. Started building equipment and then installing it, and now I'm selling it mainly. Our company is a small company, and we have supplied equipment to 40 countries around the world.
Okay, very good. Thank you. All right, Victor, how about you? Again, 30 seconds to 60 seconds.
Yes, I work for the company. The name is Synertech, Synergetic Technologies. My background goes from Soviet Union and Russia, where I get my education and got involved into powder metallurgy and HIP, pioneering the sophisticated and challenging tasks of building jet and rocket engines from powder materials. And since 2000, working in the United States, also in near net shape and net shape hipping of parts and materials for critical applications.
All right, thank you. That's great. All right, Soumya, how about you, if you don't mind, please?
Yeah, thanks, Doug, for having me, and good afternoon, everybody. My name is Soumya Nag. I am a material scientist and metallurgist at Oak Ridge National Laboratory. I work on different types of materials and manufacturing processes to get large scale components. The reason why I'm here is basically I'm leading a big effort under the Department of Energy, Office of Nuclear Energy's AMMT program, the Advanced Materials and Manufacturing Technology program, that actually looks at powder metallurgy HIP technology to make large scale components.
Okay, super, super. And we're going to talk about large scale things in a little bit here. So that's a critical part of what we'll be discussing. Mike, how about you?
Okay. Well, I'm the managing director of Isostatic Forging International, and we own, operate, and technically support about 15 HIPs around the world. I've had a lifetime involvement with HIP equipment, design, construction, operation, maintenance. I started at Battelle when I was 19 years old. I think Cliff has got me beat on the youth point, but maybe on a few other points too. And except for 6 years as a Navy pilot, I've done nothing else except HIP my entire life. Our current development efforts are very large HIPs and very small HIPs, lab scale that are tailored for additive manufacturing. So that's what we're up to.
Yeah, well, thanks. Appreciate your service, by the way, in the Navy part of it. That's great.
Well, it was great fun. Great to look back on.
Good, super. And David, how about you?
Yeah, I'm a principal technical executive in EPRI's nuclear materials area, as Doug indicated. My background's in metallurgy and welding. I guess the last 15 years or so I've spent in advanced manufacturing, looking at a variety of different topics, including PM HIP. Been in the business for roughly a little more than 40 years, so we're all getting a little gray.
That's it. Well experienced, well seasoned. So that's good. All right, Oscar, last on the list here.
Oscar Martinez. I'm the youngest of the group and learning from everybody here. So just want to make sure. I'm the regional sales manager for HIP North America. So I cover 6 different facilities in the North American market. My background is I'm a metallurgical engineer by background. Been in the oil and gas industry for about 8 years, data analysis, and then jumped into HIP and product fabrication as well. So happy to be here. Thanks for the invite.
Yeah, appreciate you joining us. All right, so let me ask you a couple of questions. I'm just going to go around the horn. Victor, maybe I'll start with you on this one. The question really deals with what have we seen recently that's been rejuvenating HIP, right? Bringing interest back to HIP. It seems like a lot of what we're hearing about HIP processing deals with 3D printing and additive manufacturing. Is that the primary driver, the new renaissance, let's say, of HIP?
No, I wouldn't say so. Basically, there are 3 areas of hipping. The one that goes steadily and rising steadily through decades is heaping of castings. You take a bad casting, I don't want to offend casting people, and bring it to the level of a better material by healing porosity, cracks, and some other things, and changing the microstructure. The second area, which you mentioned, is 3D printing, which is to some extent similar. Hipping of 3D printed part is similar to hipping castings, but there is more emphasis not on healing porosity, but on changing the microstructure and making it more uniform and homogeneous. However, the additive parts are smaller, much smaller so far, and the share of the market is not so large, but Bodycote and others probably know that better than I do. And the third is making parts from powders, which was going steadily at the relatively low level because the only or major industries interested in that was aerospace, rocket engines, and oil and gas, which is very well developed in Europe, in Sweden, for example. There's a company for decades doing very large parts for that. But recently, I mean the last 15 years, and we have to thank not only DOE, but Dave Gandy personally, who was enthusiast and pioneer, pushing this technology forward. There is much more interest from nuclear industry in replacing very heavy forgings, which take years to fabricate and still usually are not good quality by powder metals. And that thing leads to open doors in many other aspects, because most of the nuclear parts are large, and many of them are larger than the existing HIP furnaces, and so large that it requires 4 meter, 3 meter, 5 meter, whatever we can discuss. So the new drives are mainly to PM HIP are from nuclear industry for large parts, because large parts are not only large, they bring a lot of technical problems, serious problems that Soumya says he's solving, that Soumya is solving. And he mentioned in his 30-second presentation of himself, he says 3 times large-scale parts. So
Yeah.
this is important. This is very important, and this is the major perspective for HIP. Rocket engines will still be there, aerospace will still be there, but nuclear is just a new horizon for hot.
Gotcha. Well, thank you, Victor. Let's do this. David, you got your name mentioned, so let me jump over to you on this one. The question is really what's driving the new renaissance, if you will, because there's somewhat of a renaissance of hipping. I mean, there's more activity. Nuclear market, do you want to address that and tell us if you see any other drivers? And then Soumya, we will come to you too, because you got your name mentioned, so that's good.
Yeah, so
Had to
certainly in the
mention everybody.
Yeah. Go ahead, David.
certainly in the nuclear area, we are looking to build quite a number of reactors over the next 30 years. In fact, we're talking 600 to 800 gigawatts of new build, which is quite enormous compared to what we have today. A lot of that's being driven by things like data centers. There's a lot of construction of data centers planned over the next 10 years even, but certainly it will continue to grow. There's a lot of additional power that's needed for things like electric vehicles. So there's a bit of work going on around that. And just in general, as we modernize our world, electricity certainly becomes more in demand, and we have to meet those demands. The other part of this is looking at carbon issues and trying to reduce the overall carbon footprint in the world. Nuclear electric power provides a very clean generating product that can be used throughout the world.
Okay. Yeah. All right. So Soumya, how about you? It's large, as you mentioned, larger parts and things of that sort. That seems to be a driver in HIP as well. And I'll just make a quick editorial comment if I can, and please feel free to correct me because I'm certainly not the HIP expert here. But the issue with getting larger HIP parts is actually building the equipment to HIP it, because it's as the equipment gets larger in diameter, let's say, the complexity, the engineering of it becomes extremely difficult. True? And if so, go ahead and just address a little bit about the new larger parts that we're desiring.
Yeah, so there are very different aspects to what you call as large parts, right? What you mentioned in terms of parts, can you HIP large parts? That is obviously a drawback. The other is, as you go into more complex parts or one-of-a-kind parts, can you make it cost-effective, and can you make it perform as well as your cast forged counterparts? That's a big question. So Oak Ridge, so we have a sizable team at Oak Ridge working on looking at U.S. domestic manufacturing resilience. Can we actually make customized parts by different manufacturing modalities and use different materials that could fit to that manufacturing scheme to get components that are built and perform the way you want it to perform, right?
Yeah.
So PM HIP forms a big part of that portfolio. And then using additive manufacturing along with PM HIP, which we call as a convergent manufacturing, can be converged two different manufacturing modalities using similar or even dissimilar materials is something that we are extremely focused on. Now, what is the advantage of additive manufacturing? The big advantage of additive manufacturing is you get design flexibility.
Yeah.
In terms of additive manufacturing, you can end up with having customization of the parts, that helps your end product. And then PM HIP, like Victor mentioned, all the aspects of PM HIP are still good in terms of like densification, powder concentrations, and stuff like that, that are still as you would expect it to form. So you are basically coupling kind of a technology which is newer in terms of additive manufacturing, but has a greater flexibility, with PM HIP, which is a relatively well-known technology, and try to merge them together.
Gotcha. Just to wrap up this question on the drivers of this, let's talk to the guys who are out there selling this process and/or building the equipment. So, Oscar, why don't you, if you don't mind, and then Mike, I'd like to jump to you, and then Cliff will come to you last. Just briefly, what are you seeing? I mean, is it what are you told processing, changes, and then Mike will ask you the same question. So, Oscar, please.
Yeah, absolutely. And I do, Victor mentioned it, and I think that's correct. The majority of what toll hip services is going to see is castings, and that's going to be by magnitude of 60-80% of the business as a whole as of now. I have seen a lot more over the last couple of years on 3D printing and additive. And I do want to say additive has been growing in different markets as well. So on the medical market is a little bit more established, and we have seen the medical market take on some of the porous coating and those new technologies that help on the medical side. But on the aerospace market, I think it's getting closer and closer to be more of a critical component. It's still kind of a gap between those two. However, the business is starting to grow. The companies that are doing this, I'm noticing more and more starting to get involved in having additive either in-house with their own machines or subcontracting that. So, but I do agree that in the near future, castings are always going to be predominantly the factor there. And then the last thing is it's a cost. It has to be a cost analysis as well, because what I'm seeing on the additive side is, you're correct, Victor. They're looking at not only, they want to also implement rapid cooling. They want to implement different cycles and different properties to get various properties from the material itself. However, there's a difference whenever we're talking about toll hip service, that if they want to do those, then those fall into dedicated cycles, which are much more expensive. So there has to be kind of an in-between where we coach things together, we're able to put things together, because price is going to be the leader in terms of how fast it grows in the market.
Okay. And Mike, what are you seeing in your organizations?
Well, we've run about 250,000 hip cycles, and 95% of those are castings. One thing I don't know whether we've laid the foundation for what people talk about big parts and small parts. To me, a small part is something that's less than 8 inches in diameter. Medium-sized part, maybe 2 feet. Current large parts are 5 to 6 feet in diameter. And now we're trying to make parts that may be as large as 12 or 15 feet in diameter.
Yeah.
So I think that we have to have some idea what kind of scale that we're talking about on these parts. But we're essentially all castings.
Yeah.
Very little powder metal.
Okay. We are actually, one of the next questions I'm going to ask is about this large part, the 4-meter thing that the DOED's been talking about. So, but Cliff, how about you? Any drivers for HIP that you're seeing?
I would say the main thing is that as the world keeps advancing and we have higher technologies and computers with FEA and so forth, we're looking for stronger, lighter, faster materials. And that just the performance of materials in general are increasing throughout every industry, whether that's a car or an airplane or a printer. Also, the technology is spreading worldwide faster because communication and the internet, I believe. It used to be that the United States had, the lock on hot isostatic pressing, and now it's, China and Russia and other places are all on par with us, and the whole it's just kind of spreading. And it snowballs too. It started out for a long time was slow, but now it's snowballing faster and faster. So 3D and printing, yes, that's an exciting thing that has brought about new applications, but I think even the applications we've had, they're just growing faster and spreading.
Yeah. Well, as the technology spreads worldwide, I guess, right? Is it for my information, did the hipping process, was it a US based? Is that where it started? Did it start in Europe or Russia, Victor? Maybe, I don't know. Where actually did they first do? Just briefly, where did they start the first?
Mike Conaway is one of the founders. He can say a few words about
Yeah, all right, Mike, where did it start?
Well, it started well. It's like
At Patel.
who had the first airplane, but
Yeah, yeah.
everybody agrees it's the Wright brothers. So it's kind of like HIP was invented at Patel in Columbus Laboratories. I came
Okay.
to Patel a few years after it was invented, and I was in on the industrialization of the process.
Gotcha.
Obviously, some serious work has been done in Russia and China,
Yeah.
and but that's where it came from. That's where uh, Cliff's father and I worked at Patel, and we consider ourselves the fathers of the industrialization of the HIP process.
You're not going to take credit for creating it, though, for
No,
inventing
no,
it.
that's Ed Hodge, Stan Paprocki, and a guy by name Sauer.
All right. Well, your humility is showing through here, Mike.
Oh,
So that's good.
I hate that.
Yeah, yeah. All right. Before we jump onto the larger parts which we mentioned, which I think is an exciting part of this HIP and a very challenging part of it, can we address briefly, Cliff, you mentioned it about how now the technology is spreading across the world. Are there any major new players either on the manufacturing of equipment or the using of the equipment or anything of that sort around the world?
There are both in players, manufacturing and users. As far as manufacturers, we're now seeing there's 5 Chinese domestic manufacturers. There's a new one in Russia. There's one in Korea. There's one in India. So we're seeing these new companies pop up. There's a major player in Spain that's hyperbaric. They've been building high pressure equipment, but not necessarily HIP. And so we see companies like that opening up and starting to build. Whether they survive, we don't know, because HIP's an up and down market. We've seen people like Diefenbacher come and go and others come and go, vacuum generators and on and on. So it'll see how it plays out. But yes, we see new manufacturers. As far as users or toll producers, there's large companies in China now starting up. Korea has some. India is probably the next big market. It's coming. It's a little bit, maybe 10 years behind.
Yeah, yeah. All right. Anybody else want to add briefly to any new players in the market? If not, that's fine. Yeah, go ahead, Victor. Yeah.
I want Cliff to add, because Cliff has wonderful stories. We're talking mainly about metals, but Cliff is a great proponent of ceramics. And ceramics is not only great applications, but it requires different HIPs for high temperature, for high pressures. Cliff, maybe you mentioned something about ceramics, because ceramics is also the future.
Yes, we do see a lot of ceramics, everything from braces and teeth to ball bearings for electric motors, armor, boron carbide armor, military applications, hafnium carbide, niobium carbide. Those things are coming. One of the hindrances to hipping is the cost of raw materials. And so people tell us, if you could make silicon nitride powder cheaper, we'd hip everything out of silicon nitride. But
yeah,
until it happens, we're waiting. So
yeah, fair enough. Yeah, Soumya, yeah.
Yeah, one thing I want to add is we talked about hipping of cast parts of metals and ceramic materials. Hipping is also used to densify or heal additive parts as well. So you can look at AM part, and we usually go through a hipping process to kind of heal what we call the lack of fusion type of porosities, or even in some cases the gas porosities work as well. If your operating temperature is not too high, where the gas can come out again. So HIP is been used for a lot of use cases for castings, and one of the things is you can actually hip using powder where for alloys that cannot be forged. So that's another specialized use case for hipping as well.
Let's jump into this topic on the DoD and the DOE, who I understand are pressing hard the industry to come up with a 4-meter hip unit. I'm not sure who would be best qualified to address the push there and why the push. I don't know if that's Shomu or someone else. You tell me who would be
David
best.
Gandy.
David Gandy.
David, all right, David, you've been elected. Maybe you can tell us what the driving force is here and what we're trying to accomplish and why it's a challenge.
So much of this started back in probably around 2017 when we started a DOE project. In that DOE project, we were looking at utilizing the NuScale reactor design to try to produce components out of powder metallurgy HIP. We worked with Synertech quite a bit in that area, trying to build large components like the reactor head and other parts throughout. Those ultimately would go to about 10 feet in diameter. We are currently restricted right now by the size of the hip units that we've been working on, so we're only making things on the order of 60 or 70 inches. But so the real driver there is we've been pretty successful in producing very large components that are near net shape, and we would like to be able to build to expand that to be able to do very large parts. Now the 4-meter came from a little bit of the work around the projects with the Department of Energy. It also came from DoD, which was beginning to look at, can we actually make big parts for nuclear reactors that either sit on a submarine or on an aircraft carrier or other boat. How do we actually make some of those large parts? So there is quite an interest from DoD and from DOE in trying to really push the technology. And we kind of settled in that 4-meter range. It might be a little bigger, it might be a little smaller, but to make some of the large parts that we're talking about, we've got to have a much larger hip unit than is available today.
And can you tell us, David, is it the larger parts? You say they're nuclear reactor? Is that what you were saying? Or is it just a variety of different?
Parts of them are for the nuclear reactor, but there are a number of other components like large valves or large pump housings, many different components that could be produced with this technology.
So what is maybe Cliff, I'll address this to you and you can defer or deflect to someone else if you want. What are the main impediments to doing it, to a 4-meter hip unit?
Well, it's like anything that's new, there's unknowns, and the big one is the ROI and the cost of doing something on that scale. And many of us are looking at it. Companies such as Bodycote, they're considering larger units. MTC's considering larger units. The U.S. government at one time had the largest hip in the world. Now it's owned by Japan. So the U.S. government, we're hoping they'll step up and try to do a large project again. We went to the moon and we did other things, but we've kind of pulled back. We don't even have large forging capability hardly in the U.S. anymore, and we need to invest in these kind of technologies and push this forward. Yeah.
Anybody else see any other limitations you want to address?
So I'd like to build just a little bit on what Cliff said. In terms of building reactors in the U.S. to support the civil fleet, the civil nuclear reactors, quite frankly, we don't have the forging capacity in the U.S. that we once had to do that. So this would actually supplement the forging capabilities and allow us to reshore some of that capabilities in the U.S. So I'll turn it over to Oscar. I just wanted to add that clarification or addition to what Cliff had provided.
Go ahead, Oscar. Yeah.
Yeah, that is a good point, David. And there's part of part of where PM hip will jump in and bridge the gap between the two. But one thing I wanted to mention was in terms of what Cliff said about the ROI, and that's the biggest factor in terms of at least for hip companies like Bodycote and others out there. It's making sure that we have the nuclear side, which is we have seen what the ramp up is gonna look like and everything. But what else? I mean, for us, if a hip unit is not running, it's not making money. So we got to make sure that hip unit is always running. It's got to pay for itself. And then these large units are going to be in the price of it doesn't just double from the previous one. It just exponentially goes up. So
Double.
I think
It's not double. It's quadruple.
it does. So I think
Right.
one thing that I've seen in the market is if I know the DoD and DOE are working closer together to kind of have more synergy in terms of what components they need to process. But I also think that in the industrial side of things, like general industrial, anything with heavy equipment, any of those components that probably were not something liable to use of hip because of the size, because of price and things of that sort. I think it would be good to start looking at how we can incorporate those other markets to see if they would always also use some of those equipment or those hip services for their equipment.
Okay. Yeah, good.
So,
All right.
but Doug,
Yeah.
one more thing I forgot to mention was on the DoD side of the house, we have something called AUKUS, which is the agreement between Australia, US, and the UK, wherein we're actually going to be building quite a number of ships and submarines over the next few decades. Astronomically, that's going to change the way we look at our supply chain and trying to build these components. We've got to have additional forging capabilities. We've got to have additional casting capabilities. We've got to have new additive manufacturing. We've got to have hip. We've got to have it all. I mean, it can't happen without a number of different technologies engaged here.
The International HIP Committee and the event that they organize, the International Conference on Hot Isostatic Pressing, or simply HIP, most recently HIP 2025 in Aachen, Germany, is sponsoring this episode. The International Conference on Hot Isostatic Pressing is a triennial technical conference with over 50 presentations on the latest developments in the world of hot isostatic pressing. This event is a no-miss event for anyone needing to stay current in the worldwide HIP marketplace, both technically and commercially. If you'd like to receive more information about this event, please visit www.hip2025.com, or depending on what time you listen to this episode, you might want to go to hip2028.com, or you can simply search for International Conference on Hot Isostatic Pressing. You can also search the online calendar under resources on Heat Treat Today's website, www.heattreattoday.com, for the latest information. So we were talking about supply chains and the need for all of the stuff that we need to have done, additional forging capabilities, additional casting capabilities, as well as hip capabilities. And in the break that we just took, Victor was in fact mentioning that the commercial viability of the 4-meter is difficult, but perhaps the smaller units where we learn to join pieces together. Victor, could you just give us what you're comfortable giving us on that little tidbit you just told us?
No, what I said was that if Atlas HIP appears tomorrow, we are ready to make parts with it. There is powder supply, and we know how to make the cans, and with some small underwater stones, we can make the parts. But we're sitting and waiting, not sitting, but we're waiting for this HIP system at least for 10 years. And there is no commercial company to build it, and there is no commercial company to order it, unless it's a US government or Chinese government or Korean government. So the technological idea is based on very advanced development done by EPRI, and other scientists in joining already manufactured powder parts. And we did try it already. We made very large parts that were cut in half and then joined by electron beam welding. It may be the sooner route to provide US industry with very large parts, make parts as large as they can be, and then to EB welded. For example, even if we give an example, working with David Gandy's projects, new scale projects, the one part was so large that we had to split it into 6 segments. And we made the segments, and then they were successfully electron beam welded, practically keeping all the advantages of powder metallurgy and HIP, lead time, quality, material quality, faster development, so on and so forth. So this may be a very viable direction.
Yeah, yeah. Mike,
Because-
what do you think? Is that viable? Is that path to commercial viability realistic?
Well, I'm not quite sure. I call it jumbo additive manufacturing, when you make these parts that are have to be cut apart in concept and then put together physically. That's the additive manufacture of jumbo parts. So I think it's a great idea. We are looking at the same sort of a thing to make a very large hip, is to make it as a composite of segmented pieces that fit together. We call it the Lego hip or something like that. But that's an approach, and we're still working on that.
Okay. All right. Well, I'd like to wrap up the discussion. I know we're not going to get to everything we would like to get to on this extra large hipping capability. Does anybody else have anything to add to it before? I'd like to move on and talk a little bit about powder to part. But yeah, Oscar, go ahead.
Just something that Cliff mentioned also was going in between. So we've talked about Atlas, and I think Victor mentioned it right now too. And from a commercial standpoint, I think it would be beneficial for us to venture into a kind of in between size that does give us the capabilities and proves out what we have to do. That would be probably a step to the right direction of where we need to be, because it will cover a lot of the components that we're not able to see. And then oil and gas industry also has some components, and even on the IGT side and aerospace side, I know if we go in between on some of those things, they will then design based on that size. So the biggest challenge in a commercial side is the outside of large hip and everything like that. If we're looking at just commercially what hip unit makes most sense for us to run toll hip services, is always going to be between the 30 to 45 inch zone, because it's able to fill in quickly. But again, that's the biggest challenge, is if we go to an in-between larger component, what else could we bring in there that we could run all the time and make it commercially viable for whoever jumps in, if it's Bodycote, if it's anybody else, or a collaboration, that it actually makes sense to be used. So
Yeah.
I think one other thing to mention from economic standpoint is, if you're only building one 4-meter hip and you have to decide whether it goes East Coast or West Coast, that's a tough decision. But if you build a couple 2-meter hips, you could afford to put one on the West Coast and the East Coast, and you solve not only the submarine building on the East Coast, but you might solve some of the SMR building on the West Coast. So that's
yeah. Or you put a 4-meter in St. Louis, and that takes care of it all.
if you can get it there.
Yeah, if you can get it there, correct. All right, let's move on to another, and you gentlemen tell me who might best be qualified to answer this. I want to talk about powder to part. It appears to be, again, another one of the, we've heard it mentioned here, I think, already. What is it? That's the first question. What current processes might it replace? And what are the obstacles to using it? Victor, go ahead, please.
No, Shomo is the one to start.
Shomo. Okay, Shomo, you've been nominated, so you're up.
Yeah, so I'll try, and then I'll pass the baton around to other people here. So basically, the work that we are doing at Oak Ridge is basically, can you actually make custom powders and and really have a scale up of those powder production, and then utilize PM and also AM, or different type of modalities to make large scale parts, as I mentioned, customized parts. So great to talk about powder to part, which is like, hey, you get a powder, make sure you have a certain chemistry spec for that powder. Can we actually find out whether we're going to have a PM hip as a plausible way to make the part out of it, right? Make a mold and fill it up and kind of predict how the part will behave in the post hip, dimensional changes, etc., and then really inspect the properties. But then I would say there is one more caveat to it, because when we talk about powder, we have to talk about where is the powder coming from. So you rather look at the feedstock that is coming and that has been used to make the powder out of, right? So that's another side of things as well. So, and that is like, what is the chemistry of the powder, what is the shape of the powder, what is the flowability of the powder? So physical and chemical properties of the powder itself. So I'll stop there, and so maybe Dave, you can chime in a little bit.
Dave, any thoughts on the powder to part challenges or opportunities? What another question I've got here is what appears to be the most promising avenue to take to bring it about?
Well, I think one of the things that you've really got to consider for powders is powder cleanliness. We've worked quite a number of years on trying to reduce things like oxygen in the powder, so that as you consolidate that component, you don't end up with oxides that are trapped at the grain boundaries or prior particle boundaries. So it's very important that we get powder manufacturers to work with us to bring the technology forward. In addition to that, though, if we start making very large parts in a 4-meter unit, we're going to have to really scale up our powder production capabilities in the U.S. And quite frankly, that's not happened at this point.
Okay.
It's kind of the chicken and egg thing.
Yeah. They're not going to want to upgrade their powder manufacturing if there's not a market for it. So, yeah.
Exactly. One really large part may need 100,000 pounds of powder in it. One can.
Yeah.
We already did these calculations. I completely agree with David. One more piece of caveat that I want to add, if possible.
Yeah.
So from powder to part, all the processes except hipping, maybe some other ceramic, are based on melting the material and then giving it some shape. You understand, cast and wrought, investment casting, even our beloved additive manufacturing is based on melting every particle. However, when powder metallurgy started in the 80s in the US aerospace, the basic advantage it was looking at was the quality of the powder particles themselves. Because, heat treaters, that the maximum cooling rates in cooling the billet are some hundreds of degrees per minute you can reach. When the powder particle crystallizes, it crystallizes with the rate of 10,000 degrees per second. So because of its very tiny size, so it can freeze almost any type of unbalanced metastable microstructure in it. And then hipping is a solid state bonding process. Nothing is melting in hipping. So it means that during this process, we can keep this unique microstructure of the powder particles and then create and transfer this to parts of any size. For steels, it may be not so critical, but nickel-based superalloys and some other alloys, it's absolutely essential. So the caveat here is that going from powder to part via hipping, you can create very large parts with unique properties brought by the rapid solidified powder particle materials.
Okay. Yeah. Mike, anything you'd like to add on the powder to part?
No, I don't have anything to offer much there. We're intrigued with the additive manufacturing, and our focus has been on the the bed binder jet kind of thing that's based on sintering, where I think
Right.
HIP offers a lot more advantages than it does to the laser fusion approach. But
Right. Okay. Okay.
If I can add something
Yeah.
on the
Go ahead.
powder part. So from our end, we've been doing this for a while already in Sweden as well, and with the oil and gas industry being a major, almost an established process. However, one thing that I did want to bring up is not only is there a challenge with the current powder suppliers in the US, there's some movement in terms of like bringing new suppliers and everything, but the whenever we're talking about some of these components being so critical, where the powder is coming from is going to be also critical. So, like David mentioned, I think the powder, just as much as the hip, needs to be ramped up and start to build that large unit that Victor wants, just as fast as we need to do the same thing with the powder suppliers as well, because if we need to keep it in-house, we need to keep it the US, it's going to have to grow very quickly as well.
I think a lot of the stuff that was discussed, I think down at Oak Ridge recently, was from the DoD and DOE, was in fact more bringing home the supply chain, including powder production. Yeah.
Another
go ahead.
comment on powder to part, and Dave can talk to this more than I can, but it's the technology of making parts sometimes, and a lot of what we've been discussing is how to model those parts and how to predict shrinkage and those things. There's people that understand it, but making it more accessible to companies is key to expanding it.
To expanding the market for it, the demand for it. Yeah. David, you care to add anything on that?
Yeah, so we are currently working with Oak Ridge National Labs and a few others to look at bringing modeling to your laptop, basically to allow you to do modeling for the HIP process, very similar to what maybe you do with forging technologies today, where you can have that capability to do design as a conventional engineer. So what we're trying to accomplish in working on this project is really looking at how do we make modeling more mainstream for industry. As you make the modeling portion of this more mainstream, then the hipping technology becomes more mainstream. More people are exposed to it, more people are engaged in it, more companies work with it. And I'd also like to thank Victor Samarov, because Victor's certainly been a huge proponent of this and trying to help move the technology forward.
Okay. Yeah, very good. Maybe changing gears a little bit, Soumya, I'm going to come over to you on this question, and that is about Oak Ridge National Lab. I understand you guys have taken an active role in the PM HIP market. What exactly are you guys doing there? What are you hoping to accomplish?
Yeah, so like like the folks here were talking about, so one of the thing is for us to make components that are relevant towards nuclear on the DOE space and national security on the DoD space, because that's where the drivers are. So we want to basically, so first thing I want to mention is that we don't want to replace your traditional manufacturing, casting, or forging by any means. What we want to do is, as Dave was mentioning, the need for production is going to ramp up so high within US, is that we need alternative manufacturing pathways to really augment some of the troubles we have on supply chain side, right? So PM HIP is one of the technology that we have chosen among. So at the end of the day, you need to have lookup tables of different manufacturing technologies, and PM HIP is one on that chart, right?
Yeah.
So under the PM HIP, we have done basically three things. First is, can we actually use an AM, so what we call as a directed energy deposition process, or WAM, wire arc AM process, where we're basically making these 5-mile long welds, right? And that is used as a shell for the outside surface. And can that withstand the temperatures and the pressures and the times that we can think about a reactor pressure vessel, right? Can it actually withstand that cycle? So that was the big thing. Can we look at a 5 mile long weld, can AM can actually withstand that temperature pressure cycle and then move or kind of deform during the hipping process
Sure.
without a failure, right? So that was the first thing. Second is, so if you look at a hip, like a traditional hip cycle, what does that temperature, pressure, and hold time do to the material? So what are the different, and you break it up into, ramp up time, ramp up pressure, the ramp up temperature, ramp up pressure, and then hold time, etc., and see what are, microstructural changes, property changes, performance changes as a function of each of these segments that we use or take for granted for the hip cycle. So that's the more of a science-driven questions that we need to answer. The third part is, I think, where some of the challenges that we have encountered when we did a PM HIP workshop here at Oak Ridge last year in October. We had about a couple of hundred people show up from industry, from academia, from national labs, from the DoD and DOE and customers, stakeholders, etc. So the question was, what is the scalability of a part when you go for a small to large scale parts, or small to a more complex part, in terms of powder compaction, in terms of size scale of the powders, in terms of property variations, in terms of chemistry. So that is something, a PM HIP type of question that we are trying to solve. At the end of the day, the goal is to make sure that the industry can adopt this more freely and really employ it for large scale production, and then have the option using additive cans where we look at more customized kind of a shell, right? So you can use AM cans. So the good thing about AM and PM combination, if you wish to choose that, is that you can use AM can as a shell, which you can remove afterwards, or you can keep it. And when you keep it, you are basically looking at it as a hip clad type of an option where you can use similar or dissimilar materials, and depending on the functionality of the surface versus the core, you can utilize that that combination of two materials with two different manufacturing modalities.
Yeah, gotcha.
Soumya, can you add a couple of words? We had a very successful workshop organized by Oak Ridge, and we are working on another one. They are working on another one. Can you add a couple of words? It will be good if it goes by radio.
Yeah, so I think the workshop that we had in October last year was exceptionally well received from our end. So it was driven for what we call as a voice of the customers. What does the customer want from us, from everybody, to really, what are the gaps and challenges around PM HIP that would really remove some of the angst that they have, right? So that was the first thing that we did. But we also had people from powder side, from the modeling side. Victor was leading the folks. Dave Gandy was there giving plenty talks for the need for PM HIP. Cliff Orcutt was there trying to talk about the utilization of the HIP as a technology that could be used. But we had like industries from every bit of the segment come in, and they wanted to help. So the thought was, can we actually take our personal spaces out and then talk and have a cross interaction across industries to try to solve a problem on national level, right? Like Victor and Dave, you were talking, we need our government to basically push everybody and say, you know what, this is an important technology for the country. Can we move towards this? We were trying to facilitate that and say, see, this is what the voice of the customer is. This is what everybody wants. Can we actually have a demand signal? Is absolutely there. Can we actually build on it? So the next workshop that we plan on, and thanks to Dave to really spearhead those ideas, it was like, can we actually talk about real parts rather than come and talk and give your 2 cents? We actually we'll be bringing in real parts and try to see how can we make him by PM HIP, right? What are the success factors around it? I think that would be more end product driven rather than just the science part of things. We have an active PM HIP steering committee that is about 21 people that we have from industry. So Dave, Victor, Cliff, they're a part of it. They have been tremendous in terms of providing us guidance, providing
Yeah.
us less thoughts in terms of how we should move as an industry.
So Shomu, I may have missed it. Do you have that next workshop scheduled, or is it?
No, we don't
No.
have it
Okay.
scheduled, but that is in the planning process right now. Yeah.
Okay. All right. So stay tuned. We'll certainly help publish that when the time comes. So keep us posted as well, and we'll go from there.
And we have a report from the first workshop that is in limbo right now, but we will publish it, and this will be
Okay.
coming out relatively soon in terms of what we learned from the workshop, what are the gaps and challenges, and how should we move forward. So we have about 65-page report that we had compiled from that workshop.
Okay.
Again, these are the demand signals for everybody that we compiled together.
Okay. Well, you let us know if we can help you publish that as well. I mean, help you get it out to the right people. So, Cliff, I want to address this next question, changing gears a little bit to you, and then we are coming down the. I think this is the second to last question. So, I want to talk a little bit with you, Cliff, and others that want to chime in. I think Mike, you might be good at commenting on this as well, regarding the differences between toll processing and ownership of equipment when it comes to hipping. Can you maybe, Cliff, let's start with you. Can you just give us, does it make sense for manufacturing companies to send their hipping out to toll manufacturers like Mike? I think your companies do this, and Oscar, who had to peel off and actually go be with a customer. Is it better to do that, or is it better to buy your own equipment? Comments.
Those are economical things that you have to calculate and look at. Number one, if you only have one part, you're not going to buy a hip unit. But if you have the quantity and the quality and the costing works to the favor of owning your own hip unit, then you purchase it. But if you also don't have the floor space or location or people or infrastructure to support it, then sometimes it's easier to toll hip. If you're in the middle of nowhere and your parts are lead and you can't afford to ship them, then you might want to have your own hip unit located in your facility. So that all those things you look at and you analyze it and you come up with, again, if there's ROI on it and what's the best way to economically make your parts.
Yeah. Mike, how about you? Comments about toll processing versus owning your own?
I think you toll process until you can't stand the cost anymore, and then you bring it in-house.
Yeah.
When you put the investment for it. And
are there any tipping points there? I mean, what's the
I don't know how to quantify those, but I think that Cliff's remarks are well taken. It's a little bit complicated, and you have to have a believer. Let's say you're a user of hip equipment and you're getting it done by toll. Sometimes you don't want to have it. You don't have anybody in-house that has insight into hipping, and therefore is not a champion for it. But I think it remains. You just I recommend toll hipping until you can't afford it, and then we go in-house.
Yeah, it makes more sense to invest in the equipment or whatever. Yeah. Yeah, I got a kind of an odd question for you. Is there a active used equipment market for hip equipment?
There's a very much need for it. Unfortunately, there's a very limited supply of used equipment.
That's what I was wondering. I know in the thermal process side of things, the lower temperature, lower, well, not necessarily lower, I suppose a little bit lower temperature and definitely lower pressure heat treat market, there's a pretty vast market of used equipment out there, but I wasn't sure if that was the case with toll. I would assume not, simply because there's a lot fewer units in the world. But
Cliff can add to this, but our view is that the only thing that you get by getting used equipment is a little bit quicker delivery. You're going to end up spending the same amount of money.
Yeah. Okay. Yeah, that's interesting. That's interesting.
It's not a bargain.
Okay, gotcha.
Just in time.
Yeah, which is sometimes important. So that's good. All right, final question. I would just like for one or more of you to address this international HIP conference. I know that I think a number of you, if not all of you, are on the International HIP Committee, which I guess is the organization that puts the event together. Anybody care to chime in? And
Cliff.
Cliff, you have been volunteered once again, which is good. I'm glad you're here, Victor. You're the one that tells us who needs to answer questions. That's great.
Yeah, Victor's the brains behind it. I'm just the namesake. But the
Yeah.
2028 conference is going to be held in Korea, South Korea, of course,
Okay.
down in the town of Busan. It's very beautiful, and it'll be a great conference. So we're hoping to have over 200 people at it, and it covers all aspects of hipping, not just powder metallurgy, but it's all the latest technology from the makers, the toll people, everybody that's in the hip industry is usually there from all countries. And hopefully by 2028, we can have the Eastern Bloc countries there attending again as well.
Okay. And I think, if I remember correctly, it was in Columbus, wasn't it, in 2022 or something like that? And then
2022 in Columbus, 2025 in Germany.
Aachen.
It moves from USA to Europe to Asia, and every 3 years.
Okay, gotcha.
Yep.
Gotcha. Okay. And this committee that we're talking about, this is just a loose affiliation of people who have a common interest in putting this thing together?
I think trapped is a better term.
Okay.
It's
You
a
have
group of enthusiasts. Yes.
Okay, gotcha. And so the next one, the most recent one was in fact just this year in Aachen, Germany, right?
Yes.
Yes.
And there was, how many people attended that one?
250, something like that.
Yes.
150 or so?
200.
250. Okay. And I that was the other thing I wanted to get either here on the recording or from you afterwards was the website. The one that currently is up there is HIP 2025. I assume when you're ready, you're going to have a HIP 2028.
I believe it's reserved. Yes, it'll be coming online probably next year. There is the papers and so forth from 2025, I believe, have been released, and those are available to people.
Okay. All right. Sounds good. Anybody else want to comment? Have any other comment on the HIP event?
Yeah, I
You
would say so that was my first time going there in Aachen. Apart from the food and the environment in Aachen was amazing. But I felt that it was a great exposure of what the world is doing on the PM HIP side, right? It is sometimes we're bottled down in what we are doing in US, and we think we are doing the best thing in the world. That's not true. I mean, if you look at it, there are countries who are superseding, and they have ideas and thoughts and the future goals which are very, very realistically possible for them to succeed.
Yeah.
And we want to make sure that we learn from them and really act upon that.
Yeah. Great. Mike, were you going to say something about the event or no? I thought
that was
okay. All right. No problem.
Mike has
All right.
Mike has a lifetime free attendance because he received in 2022 lifetime award.
Okay. At the Columbus event.
Yes, and for the next conferences he has a free attendance.
Yeah. Very good. Very good. All right, gentlemen, thank you so much. I appreciate the time. Oh, yes, Cliff, go ahead. Sure.
One thing we might want to mention is that the powder metallurgy, the Metal Powder Industries Federation, MPIF, for about 15 years has been promoting it as a green technology. And I think that we all could agree that we should lean green towards the green things. And powder metallurgy, there's less energy usage, less machining. It's a near net shape technology. And so even if it does economically cost more, we still should look at it from that green aspect, I believe.
You're talking just about hipping general PM hip.
Yes, mainly PM, but all forms of hip would be more of a green technology compared to your big carbon melting type technologies.
Right. All right, gentlemen, thanks very much. I appreciate your time, your expertise, and it's been a pleasure talking with you all.
Thank you, Doug.
Thank you, Doug.
Thank you.
Thanks for listening and/or watching. Hope you enjoyed today's topic. Thanks also to all of the panelists for their time that they spent with us today and for their insights. To contact any of these guests, please feel free to contact me and I can put you in touch. My email address is doug@heattreattoday.com. And again, we would like to thank the International HIP Committee and the event they sponsor, the Triennial International Conference on Hot Isostatic Pressing, or simply HIP, followed by the year, either 2025 or 2028. For more information, go to hip2025.com or hip2028.com. If you like what you heard today, please give Heat Treat Radio a 5-star review or a like on Spotify, Apple Podcasts, Google Podcasts, SoundCloud, iHeart, Podbean, or wherever you watch and or listen. If you don't like what you heard here, please forget I said anything. Let us know, by the way, if you have a special topic that you would like to hear on Heat Treat Radio, and we'd be more than happy to find someone to speak on that topic. You can email your ideas to me, doug@heattreattoday.com. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. I'm Doug Glenn. Thank you for listening.